Alright, so one of the best skills that you can develop is looking through the noise, analyzing the chaos, deciding what it is that you really need to pay attention to in the assembly. So even though this this assembly looks very complicated, really there's this front disc thing, the little bend. Decide if we need to do that as sheet metal. The arm and the other little piece here. And since these are duplicates, basically we're looking at 1, 2, 3, 4 pieces that we have to draw. Not sure what 7 is. We'll have to, I guess that's one of the washer nut combinations. Okay, so 4 pieces that we have to draw, and then the main constant, well, the rod, so 5 pieces we have to draw. As we go through this process. So one of the things that will help us is coming down to the bill of materials. We do have some part numbers, so we're going to want to take a look at adding those either as a custom or in the configurations. I don't see much need for the configurations here. We could also look at some rotational and the types of fits, since this really isn't a bearing. And it is locked up with a pretty good size hex. Not sure really what's spinning or what the need there is. So either this is going to have a bushing or some type of carrier to allow it to rotate. Otherwise, what's the point? All right. So we have the wheel bracket, the wheel support, the support arm, the pivot shaft, the stationary arm, and the only thing I really would have done different here is reorder so that all of the hardware is in a group and isn't necessarily scattered between the parts. All right, so on our design, pretty straightforward, 1" 8", pretty good sized thread, locking screws. Don't see anything particularly special there. From a manufacturing standpoint, this wheel support and the naming isn't carried over real great, so we're going to apply. So I would say the wheel support is probably going to be this guy, and it shows the relief, but it doesn't really show a bearing. So even at plain carbon or steel, that's going to be able to bend 1/2 inch. That's a pretty big tonnage break, and then the shortness or the length of this leg, that's going to be a little bit of a challenge to get that bend and not have it deform and being able to maintain consistency. Jumping around my so the support arm, look at this, and it's got all of these radiuses which are real pretty, but they increase the cost. All right, so if this is a sharp edge, it creates a stress riser, but from a manufacturing standpoint, if I'm going to cast this, well, that's one thing. We still have to clean up the surfaces in a machining operation. Problem would be that if I stand this up, even 1 3/8, I stand this up and I go all the way around. Let's see, do we have a width? Well, we don't really have a width on here, so that's missing. I would assume that that's kind of in the 1/2 inch range. And over a height of 2 inches, that's going to be fairly difficult to machine, and even with a radius of, see, do we have any standard fillets? So 0.25. 2 inches long, keeping that nice straight rigid geometry going with 2 1/4, 2 1/2 inch thickness on the material, probably 1 1/2 wide. Depending on what's available. Machining it in this operation is going to be more difficult than starting off with something that's about on size and going across. And even if I had to take a ball end mill and generate this radius, but the sharps, the rounds, if I could leave those sharps or do those as red edge breaks with chamfers, I think that would make me a lot happier on the machining side. So The rounds, I don't know. I would argue against those. If they're necessary, it's one thing, but really the only two radiuses that I see as being needed are going to be for the stress riser and these two corners. The arm, pretty straightforward, or the other arm is pretty straightforward. 1.5 inches, 0.25, and we talked about the blend, and then the rod support. All right, so jumping around again. All right, so we go through this this group. Then looking at the hardware, they're using 1/4-28. There's some 632 set screws, and the goal is to build this out for whatever the assembly does, and then optimize for our manufacturer. So that being the case, I really want to look at this from the standpoint of how do I build this most efficiently. So bottom up, we have set 5-6 pieces. Their relation is already pretty much set. If I was doing this as a concept, I might consider the top-down assembly. I wouldn't go for the multi-body here unless this, well, as soon as we go to hardware, the multi-body is not going to cooperate anyway. So the individual parts, there's no great advantage to having a multi-body strategy. So top-down if I wanted to create the layouts. But we'll stay with bottom up to build the components and then assemble. So it's kind of part of our thought process to think about what the materials are, what the strategy is going to be, what exactly it is we're making, and going through the assembly process.